Hello class, it's Mr. Kaplan here, and today I will be presenting the final lesson for Chapter 4, Section 4.5 that deals strictly with mathematical model. So in the previous lesson, you learned how to manipulate variables when there are no numbers present. And in this lesson here, how that extends to what we're going to do here is that we are strictly going to be dealing with a word problem and be able to construct an expression based on what is provided to us in a word problem. So let's get right to it. So when we're modeling with algebra, it will consist of a couple of things here. Number one, obviously, it will consist of a word problem that we will need to analyze. Number two, it will consist of variables to represent unknown quantities. And last but not least, obviously, this is a math course, that it will consist of numbers. So what is very important here when we're looking at a word problem is being able to break it down to see how it applies to mathematics and to devise an expression that will help us answer questions along the way. So let's take a look at mathematical modeling and how to get this started here. So it's very important that when you're reading a word problem, again, that you understand the context of not just the problem itself, but how it relates to mathematical operations. So what we're also going to see that many of the problems that you'll encounter, there'll be more than one way to do it. And you're going to see that when you're looking at a word problem, the best way to analyze it is to take a look at the information provided for you and just make a note of anything that involves a number. So the first thing that we're going to do here is a payroll problem. And it says here, Jun owns a video store and runs a business with his two sons, Sang and Young. And Sang's earnings are 3 times more than Young's. Okay, Jun earns 400 more than Sang, and their total earnings combined is $2,500. Now, what you have to understand about this question here is that even though there are 3 people in this question here, we're going to represent all the earnings based only on one individual. So if you take a look at this question here, just to get you started, is that it tells us here, based on the scenario, that if you take a look at each paragraph there, everything is, for the most part, is compared to one person, which in this case here is Young. So we're going to let Y represent Young's earnings and then use just the Y to determine what the expressions are for the other 2 people in this problem. So you can see here that the expression Y represents Young's earnings, and we don't know that. So not only do we not know that, but we don't know the value of the other 2 people as well. So the next thing we're going to do here is we're going to use the letter Y and come up with expressions for the other 2 people, starting off with Sang. What we know about Sang is that he earns 3 times more than Young. And again, if you read that very carefully, okay, what this is going to involve is 3 times the variable. Okay, so this is just a multiplication problem involving 3 and the variable Y. So what we have there will be 3 times Y, which is 3Y. Now, keep in mind that all the expressions are with regards to Young's age, represented by the letter Y. So for this next one here, okay, it says here, June earns 400 more than Sang. Now, what you need to know about this here is that we already know Sang's expression. As you can see in the chart there that helps us organize the information, Sang's earnings is determined by the expression 3Y. Now, 400 more also can be analyzed as 400 added on top of Sang's wage. So when we do that, that will give us the expression for June's age. So the way we express June's age is 3Y plus 400. Now, the last line there for the expression is their total, which is going to be 2,500. Now, you notice on the right-hand side there for the explanation is just a way to verbally communicate what that expression means. Now, feel free to put in your own words so you can have a better understanding in your own words what those expression means there. Now, what we want to do here is now to use the expression, come up with an equation to help us solve not just for Y, but also to use that Y to determine the final answer for 3Y and then 3Y plus 400. Now, when you're looking at a total here, what you have to understand here is that we're going to take each expression, add them all up, and let it equal the 2,500. And we're going to do exactly that. So starting off with Young's wage, which is Y, we're going to add Sang's wage to it, which is 3Y. We're also going to add June's wage to it, which is 3Y plus 400. And then all those 3 expressions added together will add up to 2,500. Now that we have an expression, all we now need to do here is to simplify and solve. So remember that to simplify an expression, the first thing we need to do is to gather the variables, or to gather the like terms, starting off with the variables. So if you take a look at the left side there, we have the y, the 3y, and another 3y. And don't forget the y on its own has a 1 attached to it. So when I add the 1y plus 3y plus 3y, this will give me 7y plus 400 equals 2,500. Now, from here, what we want to do here is to isolate the y, and that will give us the first answer for the first wage, which in this case here is young. So to isolate y here, we're going to take the 400, okay, move it to the other side, and then subtract it from the 2,500, which is already there. And last but not least, we want to isolate the y here, and we just have to perform the opposite operation, which in this case here is division, specifically division by the coefficient, which in this case here is 7. And when we do that, that cancels out the 2 7s on the left side, and we're left over with 300. So what does that 300 represent? Well, if you look at the letter y, y represents Young's earnings. And now that we've solved for that, we can now change the explanation to the fact that Young earns $300. So we can now alter what we have as part of the explanation. So let's complete the table here. As you can see, Young's earnings is $300. So now that we know why, we can now solve for Sang and Jun's wage. So starting off with Sang's wage, all we need to do here is to substitute the y with the 300. And for Jun's wage, we just need to, again, substitute the y for 300 there. And the way we do that is to remember that anytime you substitute a number in for a variable, just put brackets around it. And then for the first wage here, we have 3 times 300, which gives me 900. And then in the next one here for June, we're going to replace the y here with 300. And don't forget, when you substitute the numbers, put brackets around it. And then from there, we can simplify simply by putting it into a calculator. So June's wage will be 1,300. So for these two people, Sang earns $900 and June earns 1,300. So you can see here that in this problem here, you always have to take a look at who's been referenced when it comes to the wage and the expression. Now, each expression, for the most part, when you're dealing with these type of scenarios, involves one variable, and the other expressions can be expressed with regards to that one variable, as you can see in this question. All right, so let's take a look at another question here. So this time we will be looking at another earnings problem with one slight twist, is that we will have more than one variable. So it says here, Sherry works at a clothing store and earns $9 per hour, plus 10% commission on each clothing item of clothing she sells. So what we have here is using E to represent Sherry's total earnings, H to represent the number of hours she works, and C to represent the number of clothing items she sells. Write an expression which models the situation. So what we want to do here is to find the total earnings. Okay, we know that the E on its own is going to be based on how much she gets paid per hour, okay, based on the hours she works, of course, and the commission she earns based on the clothing sales. So start off with E equals. Now, it says here that H represents the number of hours she works, and she gets paid $9 per hour. Another way to interpret this is 9 times H. Okay, so 9 times H, that's going to give me 9H. Now, for the percent commission over here, remember when we did the lesson on percents, anything with a percent sign, you need to take that number and divide it by 100 before you use it. So when you take the 10, divide it by 100, that becomes 0.1 or 0.10. So when we do that, we take that 0.10 and then multiply it to the C, and then we add it on to the 9H. So the final expression for this would be E equals 9H plus 0.10C. Now, for the next 3 questions, we're going to use that one expression and then solve for the different variables which make up that expression. So that's why for the next question here, we're always going to start off by writing down the expression and figure out what variables we will be replacing with what numbers. So start off with the first one here. It says using the expression from A, which is that, how much does Sherry earn if she works 20 hours and sells 50 items of clothing? So we know so far that E represents the total earnings, H represents the number of hours, and C represents the number of items of clothing sold. So if you take a look at the question here, the 20 hours, okay, since that represents the number of hours, that's going to substitute for the H, and the 50 items of clothing, which is the number of clothing, that replaces and substitutes in for the C. So when we replace these numbers in for those two letters respectively, don't forget to put brackets around it. And from this last step here, we're just going to simplify that. And that gives us a total here of $185. Okay, so start off this question here just by understanding the fact that in this case, the hours and the number of items clothing sold just replaces H and C respectively. Now, for the next two questions, again, we are still using the same expression, okay, with one slight twist to it. So it says here, if Sherry earns $232 and works 25 hours, this time we want to figure out how many items of clothing she sold. So starting off with $232 is her earnings. So the 232, that's going to replace the E. Okay, and 25 hours, like we saw in the previous example, okay, the hours goes in for the H. Now you're going to see in this problem, it's going to look very, very different from the previous example that we looked at. So in the next step here, the E is going to be replaced by the 232, and the H I've substituted there with a 25. Now, for this next question, you notice that on the right-hand side, we have the C on its own. So what we want to do there is now simplify the expression and then solve for the C. So in my next step, I'm just going to take the 9 and the 25, multiply them together, which gives me 225. Now, when we're isolating a variable, regardless of what side it is, you always leave the variable where it is until we have to deal with it. What that means here is that for this 0.10C, we're not going to move this. So the question is, well, what are we going to move in order to isolate the C? Well, the first thing we need to move here is this 225. Now, remember that any number and any letter that crosses the equal sign, it becomes the opposite sign once it crosses over. So we're going to take that 225, move it to the other side, and it's going to subtract itself from the 232 that's already there. And that will give me 7. Now, for the last step here, we can now take a look at the C, and you can see here that the 0.10 and the C are grouped together by multiplication. So for the final step here, we have to divide both sides here by the coefficient, which in this case is 0.10, which cancels out the 0.10, and 7 divided by 0.10 gives me 70. So in order for her to earn $232 and working 25 hours, she has to sell 70 items of clothing. Now, the next question, again, same approach. We're going to write down the expression and see where the numbers go and which variables they replace. So in this case here, if Sherry earns $112 and sells 40 items of clothing, how many hours did she work? So again, she earns $112, so that goes in for the E. And the 40 items of clothing, the 40 goes in for the C. So notice that when you substitute those variables with the numbers that we've labeled, we now have the H to be remaining. So in the next step here, I'm just going to simplify the 0.10 and the 40, which gives me 4. Now, again, you notice that the H variable here is on the right side, so it stays where it is. So we need to take care of everything else around it. So if you take a look at the 4, we're going to take this 4, move it to the left, and then subtract it from the 112 that's already there. And that'll give me 108. And last but not least, we can now divide both sides here by the coefficient, which is the number attached to the H in this case. So we divide both sides here by 9. And that will give us a final answer here of 12 hours. So Sherry has to work 12 hours and sell 40 items of clothing to get $112. So you can see here, when you're given 3 variables, as long as you have values for 2 of them, you can solve for the 3rd variable. Okay, and you saw the 3 different examples with that. Okay, this next problem is actually very similar to the first one, only because in this case here, we're going back to dealing with 1 variable. And again, this example has just been thrown out there for you to get used to the language associated with math here. So Drew is 6 years older than Rashawn. Okay. Now their ages added together is 56. Now what we want to do in this question here is we want to figure out how old each person is. Now what we know so far is the fact that we don't know either of the ages, but we just know one thing is that Drew is 6 years older than Rashawn. Okay, so we're going to let R represent Rashawn's age, which we don't know yet. So to represent Drew's age here, we just know that Drew is 6 years older. Okay, so if you want to think about raw numbers for a moment, for example, if someone's 7 years old, person who's 6 years older would be 13. So what we're just going to do here is, since R represents Rashawn's age, we're just going to add 6 to it. Okay, and their ages added together is 56. All right, so again, just like the previous question here, or sorry, the first example, what we're going to do with those two expressions is add them all up and let it equal 56. So we're going to take Rashawn's age and Drew's age and let it equal 56. So what we know so far is that Rashawn's age is R, and we're going to add Drew's age to it, which is plus R plus 6. And then from here, we're just going to solve for the R. So remember that once you get to this step over here, we want to gather the like terms. So let's start off with the letters. So we have the R's there with invisible ones in front. We're going to add those two together first. So 1R plus 1R gives me 2R. Now, what we have here, something familiar, it is an example of a two-step solution. So we're going to leave the R where it is. So if you take the 6 over here, we're going to take the 6, subtract it from the 56, and that'll give me 50. And last but not least here, we're going to divide both sides here by the coefficient of 2, which cancels out the 2 on the left side. So we know the first answer here, which is Rashawn's age. So right now, we know Rashawn's age to be 25 years old. So now that we have our first age, we can now solve for the second age for Drew here. So for Drew, we know that Drew's age is determined by the expression R plus 6. So we just need to take the 25, add 6 to it, which gives me an age of 31. Okay, so you can see here that as long as you know whose age is being referenced, you can come up with the expressions, and then from there, determine what operations you need to do in order for you to come up with the solution to the presented problem. All right, this next question over here, again, going back to understanding math terminology, what we're going to deal with here are what are called consecutive numbers, meaning numbers after another. So it says the sum of 3 consecutive whole numbers is 123. What we want to do here is determine 3 numbers. Now think about it this way, okay? Let's start off with the number 1. Okay, what consecutive whole numbers means is, well, the number right after that. So for example, if you look at 1, okay, the next number after that is 2, next number that is 3. Okay, that's exactly what a consecutive whole number is. Now, we don't even know what the first number is, so anytime you have an unknown, you always want to represent it with a variable. So we're going to let the letter N represent the first unknown number. Okay, so when you organize your chart, when you organize a problem in a chart, you're going to see that it does help you organize information. And you're going to see in this example, once we start putting the answers in, okay, you actually get to do an informal check to see if your answer is indeed correct. All right, so to fill this chart here, our first number here is N. So that represents the first number. Now, a good way to interpret how to express the second number is, well, it's 1 after the number N. So for example, if I have the number N and I add another 1 to it, the way I can express the second number is N plus 1. Now, for the third number, another way you want to look at this is the fact that we know the number N, and the third number, okay, is 2 after that. Okay, so for this one over here, we can now write the third expression to be N plus 2. So we have the 3 expressions for the 3 numbers that we don't know yet, but we do know that the 3 expressions add up to 123. So what we need to do, much like the first and the third example for today, is we need to take those 3 expressions, set them up to equal 123. Okay, so we're going to add them all up and let equal 123 here. So we're going to do exactly that. We're going to take the N, okay, we're going to add N plus 1 to it and N plus 2 to it and let it equal 123. Okay, and that's just based on, if you read the very first and only paragraph of this question, okay, this sum always means to add. So in this case, that's exactly what we did. Okay, as you can see on the left-hand side there, we have 3 sets of N's and we have numbers. So we're going to collect like terms as we have been doing. So we're going to take this N, and this third N here, group them together. We're going to take the 1 and the 2 and group those together. So in the next step here, we're going to group the 3 N's together with invisible ones. So 1N plus 1N plus 1N gives me 3N, and then 1 plus 2 gives me 3. Okay, and we bring back the 123. So notice that once you simplify this expression, we now have 3N plus 3 equals 123. okay, which is familiar because it's just another two-step solution, and that's exactly what we're going to do. So we're going to leave the 3n exactly where it is, and since the 3n and the 3 are separated by a plus sign in this case, okay, we're going to move the 3 first, take it to the other side, and then subtract it from the 123 that's already there. And for the final step, we just need to divide both sides here by 3. And we have our first number here to be 40. So what this means in this case here is that we now know the first number, which means we also know the next two numbers because, again, the numbers are consecutive. So to fill in the chart over here for the number, this is our first one here. So for the second number, we have 40 plus 1, which gives me 41. And last but not least, for the second number, we have 40 plus 2, and that'll give me 42. Now, just to do an informal check here, when I add up those three numbers, the 40, the 41, and the 42, guess what? They add up to 123. So again, you notice by setting up the chart, we did a check without us having to even think about that. Now, again, make sure that you put a sentence as well. And in this case here, therefore, the three consecutive numbers are 40, 41, and 42. So again, anytime that you don't know a certain quantity, you always represent it with a variable. And as long as you understand the relationship between the variables and what the word problem is presenting to you, solving word problems are not that difficult. All right, so that wraps up this chapter. So continue working on the review or the notebook, and I will see you in the next chapter.